creating your own classes. So the data members or member variables like X and Y inside of our point, or student name, student ID inside of the student class, provide object state, right? Because one student will have one name, another student will have another name, one point will have its own coordinates, other. So in terms of, the idea is this: if I have one point that is sitting here in this memory, and whatever its name is, PT, right? PT, right here. Then I can create another point, right? And it will be occupying, and I name it PT2 or something like that. That's silly names. But if I make my adjustment and changes in this one, the other one will not be affected. And that's what I want. That's what I want, my objects to be unique. I want to use my classes as blueprints of objects. I can instantiate them at runtime by my main function or some other executable code, but it's perfectly reasonable for me to expect that once I have instances of my points, I can work with each single one of them individually. The only way is that the only bad thing that can happen if I somehow lose track of my object and can no longer access it. That's possible. We will discuss ways to instantiate objects, and they can be local, they can be dynamically instantiated, they can be in global scope, and with all of this variety. But to begin with, it's important to understand that once you have a class, you can create multiple instances, and each single instance of them will have its own state. And that state is protected by the data members, of course, right? Because functions are going to be exactly the same, will do exactly the same thing each time you call them. However, the data inside will be different for each instance, unless you want to keep it consistent and keep them all in exactly the same state. Member functions provide, generally speaking, public interface to your class, because people, it is just such a good principle. The good principle of class design and in general object-oriented design is that people should use your member functions and not your data. More on this later. Therefore, member functions, those that are declared public, directly contribute to the public interface of your class. And you just tell your users, listen, look at the set of functions available on this class and go ahead and use them. Okay, and that is what makes class to have a publicly available interface. In addition to public interface, it's important that the class may say the details of my point or my student are quite intricate, and I want to hide it and separate it from the interface. So there is a way to add member functions which will be declared private, and those will be used internally. We'll see how we can wire it all, how the connections work and everything. But in general, class has this very natural possibility to offer you, create member functions which should be used as public interface, and also private functions, private member functions, which will be responsible for doing things internally, just doing things internally, which are not, which should not be used publicly. All right, so more examples of member functions. Recall adjust, and then we could use a draw, and we could pass some sort of canvas object to this draw method. And even here it's trying to use a pointer, because canvas is probably a pretty complicated object. It doesn't want to create a copy of it, so it's using this. Now this curious syntax here is that we say member function declarations. When we did the step towards modularizing our code and said, why don't we have separate files for our header? It's actually a great idea to define your classes, declare your classes in header files, but leave member functions without the bodies and leave them just like this by adding semicolons. You recall, this looks like a function declaration, and therefore the function definition can occur elsewhere, possibly in a different CPP file. Why this is good? It's good because this way you can keep the definitions of your class interfaces very, very clean. We can really quickly do this here in our project and then take a break. So, for example, I have a student and I also have a point, right? So I have those concepts in our program. So what I could do is just to demonstrate how really simple this is to go to our project directory and right click and say new text document and say this should be student.cpp, another implementation file, get rid of .text, say okay, let's rename it, and also right click and create a new text document named point.cpp and say yes. And by the way, before I make any modifications, I will create a new subfolder and just name it junk, so that I can grab existing versions of H and H, copy them and preserve in case if I want to post them as samples, which I probably won't. So this is before modification, and we're going to do this modification now. I just created two empty files, point.cpp and student.cpp. Then I move back to my project. I open Solution Explorer and I say, hey, I want two more source files. Source files, as you know, compared to header files, contain executable code. Header files are mostly declarations of things, so they suppose in their plain form not to contain any executable code. So it's perfectly normal to add additional source files. All right, so I'm going to say add, but now I'm going to add existing items, and I have two of them. I have point.cpp. If I can press Control button, I can actually select two files at once so that I don't have to go back to this twice, and just say add. All right, so I just added something to my project. Let's see, if I just rebuild right away, both student and point are empty files. Compiler simply ignores them. Nothing has changed. But then I would like to open point CPP and student CPP. These are just empty files. And guess what I can do at this point? I can say, okay, I have a student and a student CPP. CPP is brand new file, empty. So I can say, you know what? Instead of defining reset GPA directly in a header file, I can copy and paste reset GPA into this implementation file as is. You know, I can press Control A, Control KF to quickly format everything. Now, what I can also do here is that I can I need to specify that this definition of reset GPA is not a normal free function. It's a member function of class student. Remember std : very similarly. I can say student is a class. Class has its own scope. Inside that scope, there is reset GPA. And make sure that we want to, we want to remind the compiler and basically make sure that it knows that that reset GPA is part of the student class. And this is how it's done. The : part operator, in fact, here is the scope resolution operator. Basically saying, look, we can make sure that class is defined in the header file. We're about to include this header file here because, of course, nothing will make sense unless we say include student.h here. We can use our includes anywhere we want, and then we will say, now let's define reset GPA in this particular implementation file, which of course has a CPP extension, and now we added it as part of our project. Now, going back here, instead of now defining reset GPA inside my class, I am going to reduce this to simply function declaration, not function definition anymore. So this is how it can be done, so that you can keep your class declarations to a minimum and then define member function elsewhere. Because look, this function could take like 3 pages of code. Well, that's not good or ideal, but it could be the case. And then in this file, you've got, you can write it up. But look, your student class declaration is very clean, and you can put comments here, and people generally don't care what you do inside your functions. They say, what functions can I call? That's pretty much where, when you use string class, do you care what's the implementation of its length function? No, you just want to call length and quickly find out what is the length of the string. That's all. You don't need any details, what it does internally. So similarly with the point right here, again, I will this time clearly start with include, and I'm a little bit in a rush to make sure that our recording is not point.h. So quick, just another function here is adjust. So Control C, adjust. Control A, Control KF formats the code. Point is a class. It has its scope. In its scope, there is an adjust function. I am defining it here, and I'm going to reduce this only to just a single declaration with a semicolon in the end. Let me save everything and stop our recording. I'm just getting a little concerned about the length of it now.